This is a screencast on how to use polygon symmetry and angle properties to solve practical problems. So let's just stop for a moment and consider what this means. Now in a moment we're going to look at what a polygon is and that type of thing, but what we mean is by this piece in here, symmetry and angle properties, is what we're looking to do in this is use the existing angles of the shape to be able to find the missing angle or calculate the missing angle, and you'll see some examples. So let's look at example of a polygon. Now in front of you, these are what are called regular polygons. Now a polygon is any shape that is enclosed. So what is meant by that is that you'll see that this is closed off. There's no gap between the lines. So it's always closed off, and so you can see there's a range of shapes here, and they're made up of straight lines. Okay, and there's all sorts of ones. These are what are called regular polygons because these are the regular shapes. But you can have polygons, and if you imagine these are straight lines, something looks like this. That's a polygon. Or even more weirder, that's also a polygon, because again the shape is enclosed, and that's the key point. So what we're going to be looking at doing is seeing if we can calculate, if we have these angles here, we know what those angles are, can we figure out what this angle here is? That's what we're going to be looking at doing, and there are some quite easy rules and formula that we can follow to help us with this. So let's now move and have a look at some examples. Now this table will help you quite a bit. What this table shows is how much in a shape, how many angles in a polygon. Let me start again. What's the sum of the interior angles of a polygon? So in a triangle, as you can see, in a triangle here, it's 180 degrees. In a quadrilateral, which is any four-sided shape, including rectangle, squares, any weird-looking shapes that have four sides, it's 360. In a pentagon, it's 540. In a hexagon, a six-sided shape, it's 720. Heptagon, 900 degrees. Octagon, 1080. And there's a general we can apply to help us in case we can't remember that. And the general formula is this: how many sides there are minus 2 times 180. Now we're not going to need to worry too much about that, but that's a general formula that we use. So for instance, if we didn't know what the sum of the angles of a triangle was, we would go n minus 2 times 180. So n is how many sides? So 3. There are 3. Minus 2 times 180. 3 minus 2 is 1 times 180. So the total sum of angles is 180 degrees. Before we can calculate angles in a polygon, we need to know the sum of the angles. So this little chart here will be useful to you, and you'll see you've also got a paper copy to help you with this. So you'll see here you have a triangle, bit of an irregular triangle here, and what we're looking to do is you'll notice that we've been given two angles. 64 degrees is the angle of this one, and 42. And what we're looking to do is calculate what this angle here is, that missing angle. And so what we're going to simply do now is this. Now you'll remember last time that the sum of the whole lot of angles is 180 degrees. So here's the simple formula. We're going to go 64 plus 42, and the reason we've added those two together is that those are the angles here, plus this angle here. We're going to call that star, equals, and I've run out of room there, 180 degrees. Okay, So that's what we're looking at doing. Now what we can quickly do is go 64 plus 42 is 106 degrees. And then to calculate what the star will be, we can go 180 minus 106, which is equal to 74 degrees. So star is equal to 74 degrees. So let's just quickly go back over that, what we did here. This is a triangle, so we know that the sum of all the angles inside the triangle are 180 degrees. Then we know, so what we did first is we went 64 plus 42 equals 106. And we added those two together first so that we could see what the sum of them was. We then took this 106 away from 180 and that left us with 74. So that means that this angle here must be 74 degrees. Let's look at another example. This one here, as you can see, is a quadrilateral, a four-sided shape. So take a moment to think about how many degrees this shape, what will be the sum of all the angles inside the shape. And if you can remember, the answer is 360 degrees for a four-sided shape. So what we have to do now is, the first step we need to do is we need to add the existing angles together. So we've got 68 plus 126 plus 106. If we add that together, we get an answer of 300 degrees. And then we go 360 because it's a quadrilateral, and that's the sum of all the angles inside a quadrilateral, and we take away 300 and that gives us 60 degrees. So the answer, or x in this, x here, is 60 degrees. So give that a go. Use the table that we showed you, page that's got the different angle, the sum of all angles, or if it's a bigger shape, then you could use the formula at the bottom of the page. Good luck.